तो ଏବେ ଆମେ ଦେଖିବା most economical channel section. What are the conditions to be most economical channel section? First condition is the construction cost should be minimum, and second condition, the discharge should be maximum. And according to these conditions, there are different shapes of channels which are considered. First is rectangular, second is trapezoidal, third is circular. As we know, Q is equal to AB, the discharge is equal to area into velocity, and V is equal to C into Mi according to change is constant, and M is equal to A by P into I, and Q is equal to K into 1 by root over of P. If P is equal to minimum, then Q will be maximum. The first channel section will discuss what is the condition for most economical case, that is the rectangular section. As in the figure, the sides of the rectangular sections are B and D, and for most economical channel section, P should be minimum and dP by dt is equal to 0. A is equal to BD, B is equal to, from that B is equal to A by D, and P is equal to B plus 2D. And for that, calculating dP by dt is equal to 0, we get D is equal to B by 2 and M is equal to D by 2. These are the conditions for a rectangular channel section to be most economical. Let me see an example. And rectangular channel of wood 4 meter is having a bed slope of 1 in 1500. Find the maximum discharge through the channel if C is equal to 50. Given conditions are V is equal to 4 meter, I is equal to 1 by 1500, C is equal to 50. Then for most economical, we calculate B is equal to 2D. From that, D is equal to 2 meter, M is equal to 1 meter, A is equal to 8 meter square, Q is equal to AC into root over of Mi. From that, we will get 10.328 meter cube per second. One question is given here, you have to practice that question. Next section is the trapezoidal section. For trapezoidal section, the section to be most economical, and from that figure, these are the slopes are given in case of a trapezoidal section, horizontal and vertical slopes. From that, we get the area A is equal to B plus 2 ND by 2 into D. A by D is equal to B plus ND. And putting all these values and calculating, M is equal to D by 2, theta is equal to 60 degree, and B plus 2 ND is equal to D into root over N square plus 1. This is the conditions for a most economical channel section. And one example is there. A trapezoidal channel section has side slopes of 1 in horizontal to 2 vertical, and the slope of the bed is 1 in 1500. The area of the section is 40 meter square. Find the dimensions of the section if it is most economical and calculate the discharge if C is equal to 50. C is equal to 50, her given N is equal to 1 by 2, I is equal to 1 in 1500, A is equal to 40 meter square, C is equal to 50. And for most economical condition, B plus 2 ND by 2 is equal to D into root over of N square plus 1. Putting all these values, we get B is equal to 1.236 D, and from that, putting the values of A, area, we get area is equal to 40 meter square, and from calculating the equations for values, before we have got area is equal to 1.7360 square, and equating these values we get D is equal to 4.8 meter, and M is equal to D by 2, Q is equal to AC Mi root over, and putting all these values we get 80 meter cube per second. Next section we will consider for economical channel section, that is the circular channel section. and circular. All these sections, in all these sections you don't require the derivation, only you require the formula and you have to do the numericals. So in case of circular section, it is a the derivation is very critical. So only you know what are the conditions for economical section, conditions ଜାଣିକି ତାପରେ problem discussion ଖାଲି numericals ଗୁଡ଼ାକ solve କର। ତ same condition ସବୁ section ପାଇଁ dp by dd by here ଏଠି circular ରେ dp by d theta is equal to 0, dm by d theta is equal to 0, m is equal to a by p। ଆମେ ସବୁ value ଗୁଡ଼ାକ put କରିକି when we do the derivation we get dm by d theta is equal to 0, m is equal to 0.3d and small d is equal to 0.81 capital D. Capital D is the diameter of the channel. Q is equal to AC by mi, and from that we get small d is equal to 0.9 9.5 d for maximum discharge. Next the question, the rate of flow of water through circular channel of diameter 0.60 is 1.150 liter per second. Find the slope of the bed for maximum velocity. Calculate C is equal to 60. Here given Q is equal to 150 liter per second, from which we get Q is equal to 0.15 meter cube per second. Capital D is given, C is given. For maximum velocity, Z is equal to 0.81 D, D small d is equal to 0.81 capital D. Theta value will be 128 degree 45 seconds, or radian रे कले हमें कहिबा 2.247 radians. M is equal to 0.3 D. We calculate M from here 0.18 meter. P is equal to 2 r theta. M is equal to A by P. Area will be equal to 0.2426 meter cube. Q is equal to AC root over of mi, from which we calculate I is equal to 1 by 1647, sorry 1694.7. Next we will see what is hydraulic jump. So hydraulic jump in general meaning, if we actually in a practical language or in general simple language will this is the jump of a water. Hydraulics means the jump of a liquid from a higher velocity to a lower velocity, due to which the depth of water rises. The depth liquid surface rises, which is known as hydraulic jump. A definition, it is a simpler definition is that it is a phenomenon of hydraulics which is frequently observed in open channels flow in rivers and spillways when a liquid at high velocity discharges to a zone of lower velocity. Rather abrupt rise occurs in the liquid surface, which is known as hydraulic jump. In technical language, in our language, it is defined as the rise of water level, which is taking place due to transformation of the unstable shooting flow. Unstable shooting flow means the supercritical flow to stable streaming flow, that is known as subcritical flow. Supercritical flow, subcritical flow we had discussed in the first open channel flow 1. So देखियो फ्रंट नंबर केते हेले कोन लेस देन 1 हेले कोन हबो सबक्रिटिकल फ्लो, इक्वल टू 1 हेले क्रिटिकल एंड ग्रेटर देन 1 हेले सुपरक्रिटिकल अकॉर्डिंग टू फ्रंट नंबर। सी केस रे हम देखियो जदि फ्लोटा चेंज होची फ्रॉम सुपरक्रिटिकल टू सबक्रिटिकल हमें ताको कहूचे हाइड्रोलिक jump. When a sharp change in the channel slope is there, hydraulic jump will there. At the toe of the spillway or dam, hydraulic jump is there. This completes your open channel flow.